Hi, welcome to another video. Hope you had a good Christmas and New Year celebration. So you can see the date, Sunday, January the 2nd, 2022. If there's one thing I hate on this microcontroller, it's having to plug it into my programmer, find the C file and update the time on the real-time clock calendar. So since it's Christmas, I thought I'd treat myself and add GPS. So on this video, I'll show you how to decode just some of the basics on the GPS receiver. I'll show you how to find the sentences and pick up the time and update the real-time clock calendar. This currently updates the time when I first power it up, but what I intend to do is have it power up every month or so just to update the time. The only downside to a GPS is this needs to be near a window. This came with a Nixie clock many years ago. This one runs off 5 volts on the tip, ground at the end and the signal in the middle. This is a 3-meter audio cable, so that plugs into there. To get the data from the GPS, you need to know what sentence you're going to look at and where the time is in that sentence. So today I'll show you how to do that on my ZeroPlus Logic Cube. Now this one's actually a 32 channel, but the decoding I'll show you in a second is all available on the entry level. So this ZeroPlus Logic Cube can decode 120 protocols: UART, I2C, CAN, LIN. So let me put this out the window. I'll connect this and show you on the screen how it works. Let me open the ZeroPlus software. Right, so I won't cheat. I'll start from scratch. So this is the usual tipset startup that many programs offer you. So the easiest way, I just want one channel. I'm going to delete all these channels on the left. You would either have 16 or 32, depending on the model of your analyzer. So channel assignment. Add bus signal. So this is just one signal. I'm going to use pin 0 of port A. Because it's UART, I'm going to group it into a bus. Group into bus. So bus properties. Click in here, the protocol decoder. I want UART, so type in U for UART. USB 2, USB 1, USB 3, up-down counter, Uni and UART. Configuration, you can leave this at the default settings. So OK. So at the top here we want to capture nothing in front of the trigger. As a rule you set the internal clock of your analyzer to 4 times the frequency of the device you're sampling. So since we've got a baud rate of 9600, 9, 18, 27, 36 kilohertz. So we've got 1, 5, 1 kilohertz, 5 kilohertz, 25, we'll go for 50. And choose the memory. I think the largest memory on the entry level is 32K, which is actually quite sizable for one string of data. So let's try that. All we have to do now is hit play. So in the navigator window down the bottom, you can see there was a long wait before we got some data. So what I forgot to do was compress the data, and the Logic Cube fills its memory with data and no empty spaces. So back up to here, acquisition setup, compress data. I forgot that bit. If you've got a 32 channel analyzer and you compress the data, you can only use 16 channels. So go OK. Now let's try this capture again. I can either press a button on a Logic Cube or press play up here. And see, filling the buffer on the right hand side. It should take a while, 32K is sizable. There we go, there's our data. I can zoom in using this button or zoom out here. Let me zoom out. Right, there's our data here. If I use the window down the bottom. So these grey bits in the middle, it looks like the UART is on and it's capturing something, but there's actually nothing there. So this is the navigation window down the bottom. Let's just start here. Zoom in here. So this 24 is the start of this block down here. So if you're familiar with ASCII, you should know 24 is actually a dollar sign. So rather than decode with hexadecimal, you can decode with ASCII. There we are, and there's a dollar sign. So this is the start of the first sentence. So the first sentence, $GPGGA. And to make things even easier, rather than have to scroll all the way along the top for the next sentence, I can simply hit the binoculars, find a sequence, and as it says there, type in data, then a colon, then a dollar sign. Go next. There's the start of one sentence. Next. So you can see we're still in this first block of data down here on the left. This is the next sentence. Next sentence. Next. Then a long pause. So I don't know what the UART is doing here. So this memory is not empty. There was something recorded here, or the data line was high. So it's not nothing, it's the data line was high. So it recorded it. Next, 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 next. But to make things even easier, close this for a second. Go to View, Packet List. If I bring this bottom up, these are all the packets. So we know each sentence begins with a dollar sign. So bring the binoculars back up. The dollar symbol is still there, so next. So there's the dollar sign, hexadecimal 24. In fact, settings, we can change this to ASCII as well. ASCII. OK. Right, there we go. $GPGGA. That's the first sentence. Next. GPGSV. GPGSV, another one. That's the same, that's the same. Right, there we go. After some homework, this is the one I'm actually interested in. The GPRMC. Find your data easily just by clicking on the binoculars and typing your code in here. If you're decoding hexadecimal, you have to put hexadecimal here. If you're decoding in ASCII, you can put an ASCII character here. The hexadecimal value for a dollar symbol is hexadecimal 24. So if I put OX24, next, search failed, and that's because I'm decoding in ASCII. So if I change this up here to hexadecimal, now look for 24. There we go, it's now finding the 24s. So that's important. Depending on how you're decoding your data, you have to look for the same sort of data that you've previously set up here. So if you don't want to mess about on a PC, the best thing you can do is actually export all this data. Export it to a text file. So packet text, save in documents. There we go. So this is the current condition of the analyzer. So you can see it's a 32 channel. So channel names here. And I had no filters. And it automatically picked up the first bit of data, which is a dollar symbol. So if I scroll down, if I see the little square on the right here, you can see this is a big text file. So that's today's date, 2nd of Jan 2022. Sampling rate 50 kilohertz. I would be lost without this analyzer. If you've seen my CAN decode on a car, I use this decoder because my expensive oscilloscope has got a tiny amount of memory and couldn't capture enough data to decode the CAN bus on my car. What I've done is prepared this from earlier. So I captured a ton of data and I found the ID I was interested in, this GPRMC, and I want the time. If I quickly show you this, I drew on paint earlier. Most GPS receivers use this format. You need 4 or more satellites to give you an accurate location. This is my sentence, GPRMC. Every bit of data has got a delimiter, or this comma means it's the end of that specific type of data. So this first bit of data is the ID. The second bit is the time, UTC. The third bit, I've got a note down here. If there's an A, the time is valid. If there's a V, it's not valid. I don't know why they chose an A for valid and a V for not valid, but there you go. This is the latitude, north, because I'm in the northern hemisphere in the UK. And this is the longitude, and then you get west or east. This particular sentence is giving you the speed across the ground. So this is currently showing 0.09, is that kilometers an hour, I guess? But this figure, in conjunction with some of the other sentences, would actually give you a proper fix. And with the other sentences, it would show I'm not actually moving. So this is the speed, and then the track is at 144 degrees, I'm not sure. And then the last one is the date, 14th of the 11th, 2012. There's 2 bits of data missing, but we'll forget those. And the CRC checksum at the end. I'm interested in this time here. If I go to my saved text file, so the packet numbers was like 300 and something, and so I just renamed them. So the sentence starts with $, GPRMC, comma, then you can see the time, 17:20 and 39 seconds, .000 UTC. The important number is this packet 18. It's giving me an A, which means the time is valid. So all I have to do is set up some C code to capture these bits, confirm bit 18 is an A, then update my real-time clock calendar. And that's it, it's done. So when the data coming in equals decimal 36, if I pull up the ASCII chart, decimal 36 is a $sign, or as you previously saw on the decoder, hexadecimal 24. So when it sees the $sign, it resets the counter to 0 and then starts counting. And if the string coming in is greater than 63, I chose 63 because I've previously been capturing the date. That's now sort of commented out. So when the string is over 63, I check that bit 3 is equal to an R, bit 5 is equal to a C, and bit 18 is equal to an A, which means the time is valid. It actually displays the time, then the GPS hours, converting from ASCII back to decimal, so it's 10 times this first digit, and then the last digit, 10 times this digit, then the last, and then 10 times this digit, then the last, subtract 48. So why do you subtract 48? If you look at, on this ASCII chart, decimal 0 is ASCII 48. So you subtract 48 from your result to convert it back from ASCII back to normal decimal. So there's my GPS hours, minutes and seconds. I say the time is equal to 1 after it's done that, and it jumps to this loop. So once the time is equal to 1 here, it stops looking at the UART and updates the time here. GPS hours, minutes and seconds plus 1 because of the time it takes to update. And then current date, current weekday, current month and current year. I'll put this file on GitHub and put a link in the show more. You can have a browse. So if you're interested in logic analyzers, head over to the debugstore.com. This is the entry level, £155 plus the VAT. But there's a ton of analyzers, compilers, programmers, test equipment. I'll put a link in the show more to go and have a browse. Treat yourself to a new logic analyzer or a new compiler or development kit. So this has been a brief look at decoding GPS for any microcontroller. It doesn't have to be a PIC microcontroller. Hopefully you found this helpful. If you found this helpful, don't forget to click like. Thanks for watching.